Welcome back. I am the Body Whisperer, and I am glad you are here. Before we begin, let us settle in together. Find a comfortable position. Let your arms grow heavy, your legs, your shoulders. Take a slow breath in and let it go. One more, in and release. Good. Now, while you rest here doing nothing at all, something quiet is happening inside you. Your body is working. It always is, every hour of every day, without ever asking for thanks. I want you to get to know it a little better, to listen to it, to feel it, to appreciate it. Because the more you understand the quiet world beneath your skin, the more at home you feel inside your own body. So, come and meet Liver Lisa, one small part of you that keeps working through the night while you sleep. This is the story of 2 hours of bile and alcohol science to fall asleep to. There is nothing you need to do now, nowhere to be, nothing to figure out. Just breathe, close your eyes if you have not already, and let us begin. Every time you eat a meal with fat in it, a handful of almonds, a piece of salmon, a pat of butter on warm bread, something has to happen deep inside you, or none of that nutrition ever arrives. The fat-soluble vitamins, the ones that keep your bones solid, your immune system awake, your blood able to clot, they are sitting right there in your food. And without one particular thing that your liver makes, they pass straight through you and are gone. Tonight, you are going to find out what that thing is, where it comes from, and why the organ making it quietly runs the most complicated night shift in your entire body. Welcome to the liver. Not the textbook liver, not a diagram. The actual place, a dense, warm, rust-red organ tucked under the right side of your rib cage, roughly the size of a football, weighing somewhere around 3 pounds. It is the largest solid organ you have. It sits there without complaint and does more simultaneous work than any other organ in the body. It metabolizes, it detoxifies, it stores vitamins. It makes proteins your blood cannot live without. It handles most of the drug biotransformation in your body, meaning it is the organ that chemically transforms medications into forms you can use and then clears the byproducts away. It runs ketogenesis, glycolysis, lipogenesis, glycogen synthesis. It breaks down heme, the iron-carrying molecule in old red blood cells, into bilirubin, and then conjugates that bilirubin so it can be safely excreted. It participates in immunity. It shapes digestion. And it does all of this without a single conscious instruction from you. At the center of the liver's night shift is Liver Lisa. Lisa is the department head here. She is patient in the way that only someone who has managed truly complicated logistics for a very long time can be patient. not because nothing bothers her, but because she has learned that urgency is a tool to be used precisely, not constantly. She has a clipboard. She always has a clipboard. Her job description is longer than most contracts, and she stopped reading the fine print years ago because she already knows what it says. The work is the work. It does not wait. When the lights in the rest of the body begin to dim, when breathing slows and muscles ease, and the conscious mind lets go, Lisa's department does not wind down. The night shift at the liver is not quieter than the day shift. It is different. The incoming traffic changes, the priorities shift, and as sleep begins to deepen, Lisa is already moving. Her first order of business, as always, is bile. Bile, the word does not sound glamorous. It has a reputation, mostly borrowed from old insults about temper and bitterness. But inside the body, bile is something else entirely. It is a carefully engineered aqueous solution, meaning it is water-based, produced and secreted by the liver's working cells, the hepatocytes. The hepatocytes are the main cellular workforce of the liver, the ones doing most of the metabolic heavy lifting. They make bile continuously. They do not wait for a meal to start the process. Once the hepatocytes produce bile, it does not travel directly to where it is needed. It moves through a branching network of tiny tubes called bile ducts. And here is something most people never learn. The cells lining those ducts, the cholangiocytes, are not passive pipes. They actively modify the bile as it flows through them. They add water. They add bicarbonate. They adjust the composition. The bile that arrives at the end of the line is not identical to the bile that left the hepatocyte. It has been worked on in transit. The destination, when no meal is calling, is the gallbladder, a small pear-shaped storage pouch tucked just beneath the liver. The gallbladder concentrates the bile, pulling out much of the water and holding the rest in reserve. Think of it as a loading dock that keeps inventory warm until there is a truck to fill. When a fatty meal arrives in the small intestine, a signal goes out, the gallbladder contracts, and that concentrated bile is released into the intestine where the work begins. And the work is this: bile salts, one of the main components of bile, along with phospholipids, cholesterol, conjugated bilirubin, electrolytes, and water. Bile salts are the ones that make fat digestible. Fat does not dissolve in water. Your intestine is a watery environment. Without help, fat would sit in large, greasy globules, and the enzymes that are supposed to break it down could only work on the outside surface. Bile salts are the help. They are amphipathic, meaning one end of the molecule is attracted to water and the other end is attracted to fat. They arrange themselves around fat droplets and break them into smaller and smaller pieces. That process is emulsification. And once the fat is broken down into its components by digestive enzymes, the bile salts do something even more important. They form structures called micelles, tiny organized assemblies, essentially molecular ferries. And those micelles carry the fat digestion products across the watery intestinal environment and deliver them to the intestinal wall. Here's the part that lands differently once you understand it. The fat-soluble vitamins, A, D, E, and K, travel inside those micelles. They have no other way across. If the bile salts are not there, the micelles do not form. If the micelles do not form, vitamins A, D, E, and K do not get absorbed, not reduced, not delayed, simply not absorbed. Lisa makes the thing that makes that possible. She has been making it all day, and she will make it all night. She is just getting started. So let's slow down for a moment and take a closer look at what Lisa is actually building. Bile is not a single substance. It is more like a carefully blended recipe, a water-based solution with several distinct ingredients, each one there for a reason. Lisa does not throw things together haphazardly. She has been running this operation long enough to know that every component earns its place. The main players in bile are bile salts, phospholipids, cholesterol, conjugated bilirubin, electrolytes, and water. That list sounds like a chemistry exam. So let's just walk through it like a kitchen pantry, shelf by shelf. The bile salts are the workhorses. They are derived from cholesterol, which is already interesting because cholesterol gets such a bad reputation that people sometimes forget the body uses it to build essential things. Lisa takes cholesterol and transforms it step by step into bile acids. Then she attaches a small molecule, either glycine or taurine, to make it water-soluble. That attachment step is called conjugation. The finished product is a bile salt, one end that likes fat, one end that likes water, a tiny two-faced diplomat that can work in both worlds at once. That two-faced quality is the whole point. When bile salts meet a fat droplet in the small intestine, they arrange themselves around it, fat-loving ends pointing inward, water-loving ends pointing outward, and they break the droplet into smaller and smaller pieces. This is emulsification. Think of what dish soap does to a greasy pan. The bile salts are Lisa's dish soap, and the small intestine is the pan. But emulsification is only the first step. Once the fat is broken into fine droplets, the bile salts do something even more elegant. They organize themselves into tiny spherical structures called micelles. A micelle is essentially a small transport capsule, a hollow ball with a fatty interior and a water-friendly exterior. Inside that ball, the products of fat digestion can hitch a ride. And crucially, the fat-soluble vitamins A, D, E, and K can climb inside as well. This is the moment that most people never hear about, and it is worth pausing on. If Lisa does not make enough bile salts, or if the bile duct is blocked, or if the gallbladder is not releasing bile when it should, the micelles do not form properly. And if the micelles do not form, the fat-soluble vitamins cannot be absorbed, not reduced, not slightly lowered. They pass straight through. Vitamin A, which the body needs for vision and immune function. Vitamin D, which helps regulate calcium. Vitamin E, an antioxidant working quietly in cell membranes. Vitamin K, which the body needs to make several of the proteins involved in blood clotting. All of them depend on Lisa's plumbing. Every meal, every supplement, every careful dietary choice. The fat-soluble ones only arrive if the bile is there to carry them. Now, the phospholipids in bile, mostly one called phosphatidylcholine, serve as a kind of structural support for the micelles and also help keep the cholesterol in bile from crystallizing. Cholesterol on its own does not dissolve well in water. Without phospholipids and bile salts keeping it in solution, it would start to clump. That clumping over time is one of the ways gallstones can form, but that is a longer story for another time. The conjugated bilirubin in bile is waste. Bilirubin is what the body produces when it breaks down old red blood cells, specifically when it dismantles the heme portion of hemoglobin, the molecule that carries oxygen. Lisa takes the raw bilirubin, which is not water-soluble on its own, and conjugates it, attaches glucuronic acid to it, making it water-soluble so it can be excreted. It flows into bile, travels to the small intestine, and most of it eventually leaves the body in stool. Bilirubin is why stool is brown. That is not a footnote. It is a direct consequence of Lisa's work, visible every single day. And then there's the water and the electrolytes, sodium, potassium, chloride, bicarbonate. These are not passive bystanders. The bicarbonate, in particular, helps neutralize the acidic contents arriving from the stomach. The small intestine prefers a more neutral environment, and bile helps create that. Now, all of this bile, this carefully prepared solution, does not flow directly into the small intestine at the moment Lisa makes it. It travels first down the bile duct toward a small pear-shaped storage organ tucked just beneath the liver, the gallbladder. There it is concentrated. Water is pulled out, which makes the bile salts and other components more potent. The gallbladder holds the bile in reserve, waiting for a signal. That signal comes when food, particularly fat, arrives in the small intestine. The intestinal wall releases a hormone called cholecystokinin, and cholecystokinin tells the gallbladder to contract and release its stored bile into the digestive tract. In the middle of the night, while the stomach is quiet, the gallbladder is mostly patient. It is holding its reserves. Lisa is still producing bile. Hepatocytes never fully stop, but the demand is low, the flow is gentle, and everything is proceeding in an orderly way. Lisa, for her part, is moving on to the next item on her list, because bile is only one thing she does, and the night has a great deal further to go. So bile is handled. The fat-soluble vitamins are in their micelles, the gallbladder is resting, the cholangiocytes have done their quiet modification work along the ducts, and Lisa has crossed that one off the list. Now she turns to her clipboard. Here is a thing worth appreciating, slowly, before sleep takes you any further. The liver is not a specialist. Every other organ you can think of has a clear primary job. The heart pumps, the lungs exchange gas, the kidneys filter. Even the brain, as complicated as it is, has a headline. It processes, it coordinates, it thinks. But the liver does not have a headline. It has a list. And the list goes on in a way that genuinely defies a tidy summary. Lisa, standing at her station somewhere deep in the right side of your abdomen, does not have one department. She runs several. They do not pause while the others run. They run together all through the night, all at the same time. Let's walk through the departments slowly, not to overwhelm you. Just so you know what is actually happening while you drift. There is metabolism. That word gets used loosely in the world, but here it means something specific and vast. Lisa manages how the body handles carbohydrates, storing glucose as glycogen when there is plenty, releasing it when there is not. She manages fat, building it when energy is surplus, and breaking it down when it is scarce. She manages protein, not just using amino acids, but transforming them, routing them, disposing of the ones that cannot be used directly. Metabolism is the steady hum in the background of every other task. It never goes quiet. Then there is immunity. This one surprises people. The liver sits in a privileged position along a route called the portal circulation. The blood coming from the intestines flows directly through it before going anywhere else in the body. That means the liver sees everything that crossed the gut wall. Nutrients, yes, but also bacteria, fragments of old cells, and things that simply should not have made it through. Lisa's department has specialized immune cells, Kupfer cells, if you want the name, stationed along the blood vessels like quiet security guards. They do not announce themselves. They simply catch what the gut sends up and handle it before it reaches the rest of the body. The liver as immune organ. Most people never think of it that way. Then there is detoxification. This is perhaps the one people do associate with the liver, but even here the full picture is larger than most imagine. Detoxification is not a single reaction. It is a whole workshop. Compounds that arrive in the blood, some from outside, some generated by the body's own chemistry, are taken in, transformed, and packaged for removal. Drugs follow this path. So do many hormones once they have done their work. So do the breakdown products of normal cell activity. Lisa's detoxification department runs two overlapping phases. In the first, enzymes modify the incoming compound, often making it more reactive. In the second, other enzymes attach a water-friendly tag so the whole package can be carried out in bile or urine. It is not dramatic, it is systematic. It runs continuously. Then there is vitamin storage, not just production or processing, actual storage. The liver holds meaningful reserves of vitamins A, D, B12, and others, tucked away against the possibility that the next meal does not arrive on schedule, or that the next few meals are not quite what they should be. Lisa's department is not just a factory, it is also a pantry. Then there is a cluster of synthesis jobs that belong together. Ketogenesis, the production of ketone bodies when carbohydrate fuel is running low and fat needs to be converted into something the brain can actually use. Lipogenesis, building new fats from excess energy. Glycogen synthesis, taking incoming glucose and linking it into those long branched chains for storage. Glutamine formation, making an amino acid that feeds other cells, including the cells lining the intestine. These are not rare emergency functions. They are part of the regular rhythm, shifting in emphasis depending on what the body has just eaten, how long ago it last ate, and what the rest of the body is currently asking for. And then, because the list has not ended, there is heme. Red blood cells do not live forever. They circulate for a few months, and then they are retired. When they break down, the iron-containing pigment at the center of hemoglobin, heme, cannot simply be discarded unchanged. It has to be processed. The liver takes heme, breaks it down through a series of steps, and the end product is bilirubin, that warm yellow-orange compound we met in the last chapter, the one that gets conjugated and mixed into bile and eventually colors stool. Lisa's department is, among all its other duties, the place where old red blood cells complete their final transformation. The body reclaims the iron, the heme is converted, and the bilirubin gets sent on its way. Metabolism, immunity, digestion support, detoxification, drug processing, vitamin storage, ketogenesis, lipogenesis, glycogen synthesis, glutamine formation, heme breakdown, and bilirubin conjugation. None of these are side projects. All of them are running, more or less, right now. Lisa does not complain about the list. She has never complained about the list. She simply works through it, department by department, hour by hour, in the dark and quiet of your abdomen, while the rest of you sleeps. What she does not know yet, what no one in the department knows yet, is that the second half of the shift is about to get complicated. Something is coming down the portal vein, and it is not a nutrient. Lisa had been expecting something like this, not predicting it exactly, just the way an experienced night shift worker develops a sense for the shift in air pressure before the difficult part of the evening arrives. The bile work was steady, satisfying, the kind of chemistry she could do with her eyes half open. And then the portal vein, the great incoming highway that carries everything absorbed from the gut directly to the liver, delivered something different. Ethanol, alcohol, 2 carbons, 1 oxygen, very small, very soluble, and in no hurry to announce itself. Here is the thing about ethanol that most people never quite appreciate. It does not require a transport system. It does not need a special receptor or a dedicated carrier protein to get inside liver cells. Through membranes, the way morning light comes through a thin curtain, quietly, completely, without asking permission. By the time the liver has registered that it has arrived, it is already inside. She did not panic. Panicking is not in her job description. Instead, she did what the liver has always done. She reached for the tool designed exactly for this molecule, an enzyme called alcohol dehydrogenase. It lives in the fluid-filled interior of liver cells, the cytoplasm, waiting, patient as a coat check attendant, for ethanol to come through the door. And here is where the chemistry gets interesting. When alcohol dehydrogenase gets to work on ethanol, it does not simply neutralize it or dissolve it into nothing. It converts it. 1 molecule of ethanol becomes 1 molecule of something called acetaldehyde. That name is worth holding for a moment. It is smaller than ethanol. It is more reactive than ethanol. If ethanol is a guest who wanders in uninvited and sits on the couch, acetaldehyde is that same guest after 2 cups of coffee, moving around, touching things, rearranging objects on the shelf. Acetaldehyde is chemically restless. It forms bonds with proteins it was never meant to encounter. It modifies them, altering their shape in small ways that do not go unnoticed. But acetaldehyde itself is not the only consequence of this first conversion. There is a second product of the reaction, and in some ways it matters even more to what happens next. That second product is NADH. To understand why that matters, you need to meet NAD plus Nancy, a small, flat molecule that looks a bit like 2 connected ring clusters, blue-gray and quietly luminous in the dim light of the cell. Nancy is a molecule called nicotinamide adenine dinucleotide, and in her active form, she carries a positive charge, NAD+. In the plainest possible terms, she is one of the most important electron transporters in the entire body. Hundreds of chemical reactions depend on her. She accepts electrons, she donates electrons, and she keeps metabolic traffic moving in every direction at once. Nancy is never idle. That is her nature. But here is what happens when alcohol dehydrogenase converts ethanol to acetaldehyde. The enzyme pulls a pair of electrons off the ethanol molecule and hands them to Nancy. Nancy accepts them because that is her job. And in accepting them, she shifts. She is no longer NAD+. She is now NADH, the form that has taken on electrons and is holding them. Nancy, if asked, would describe this calmly. The ratio has shifted, she would say. That is simply a fact. More NADH than NAD+. The ratio tells the story. And the ratio, it turns out, tells quite a lot. Because NAD+ is not only required for alcohol metabolism, it is required for a long list of other reactions happening throughout the cell simultaneously. Fatty acid oxidation needs it. The citric acid cycle, the cell's central energy generating loop, needs it. Gluconeogenesis, the process of building new glucose from raw materials, needs it. When ethanol arrives in volume and alcohol dehydrogenase gets busy, those NAD+ molecules are being recruited rapidly into NADH. The available pool of NAD+ shrinks, and the reactions that needed those NAD+ molecules find the supply line suddenly tighter than expected. If that last word, gluconeogenesis, rang a faint bell, it should. Because in the previous episode of this story, Glucagon Gerald, the body's blood sugar ambulance, a compact amber gold peptide who spends his entire existence responding to low glucose emergencies at inconvenient hours, discovered that his orders for new glucose were not being filled the way he expected. Gluconeogenesis, the very process he depends on, had slowed. The liver was not keeping up with his requests. The reason, which was named but not fully explained in that episode, was a rising NADH level. And now you are watching that NADH rise in real time. It is the same molecule, the same ratio, the same mechanism. 2 episodes, 1 thread. Lisa kept working. Alcohol dehydrogenase kept converting. Nancy kept accepting electrons and shifting from NAD+ to NADH. The ratio crept upward, steadily, with no alarm and no announcement, because biochemistry does not use alarms. It simply changes the numbers, and the consequences follow the numbers like water follows a slope. Somewhere in the gluconeogenesis department, the work was already beginning to slow. And in the loading dock of the liver's glycogen warehouse, a warm, honey-brown figure named Glycogen Gary was looking at his outbound shipment queue and doing the kind of quiet arithmetic that late-shift logistics managers do when they already know the answer, but check the numbers anyway, just to be sure. The numbers were not encouraging, but that part of the story is just beginning to unfold. So here is where the story takes its first real turn. Acetaldehyde, the molecule that alcohol becomes the moment it steps through Lisa's door, is not content to simply exist. It does not sit in a corner and wait to be dealt with. It moves, it reaches, and what it reaches for is whatever is closest. In biochemistry, there is a word for this kind of molecule: reactive. It means the same thing it sounds like. This molecule is looking to form new bonds, and it does not always ask permission first. What acetaldehyde finds in Lisa's cell are proteins. Proteins are everywhere. They are the workforce of the cell, the enzymes that carry out every reaction, the structural scaffolding that holds things in their proper place. And acetaldehyde, being reactive, attaches itself to them. Not gently, not reversibly in any easy sense. It modifies them, changes their shape, changes what they can do, sometimes changes them so thoroughly that they can no longer do their jobs at all. Imagine a well-organized office where every desk has a specific function. The person at the accounting desk runs the numbers. The person at the shipping desk moves packages. Now imagine someone wandering through that office with a stapler and randomly stapling papers to the wrong desks, jamming drawers, sticking files to keyboards. The office still looks like an office. But things are no longer working quite right. That is approximately what acetaldehyde does to proteins. The technical term for this process is adduct formation. The acetaldehyde bonds to an amino acid on the protein and creates what is called a protein adduct. And altered proteins look different. They look to the immune system like something that does not belong, which is precisely when inflammation IDA notices. IDA is the body's fire alarm, a radial burst of warm red-orange clay, short, irregular spikes radiating outward from a central rounded face, small arms tucked close, watching constantly for signals that something has gone wrong. Her job, in the simplest terms, is to detect damage and respond. Acute inflammation is one of the body's most elegant emergency systems. When IDA fires in the right context, a cut, an infection, genuine tissue damage, she coordinates a response that protects and begins to repair. But IDA does not evaluate intent. She does not ask whether the modified proteins arrived because of an infection or because of a glass of wine. She observes. Something in the cell looks structurally wrong. A protein has been altered in a way that reads as damage, and so she responds accordingly. She noted in her calm and methodical way that modified proteins were accumulating in Lisa's workspace. Not a flood, not yet, but enough to register. The signal she sends through a family of chemical messengers called cytokines and through a master switch in cellular biology called NF-κB signaling tells nearby cells something is happening here. NF-κB, pronounced roughly as it looks, is a protein complex that acts as a kind of alarm relay station inside the cell nucleus. When it gets activated, it turns on genes related to inflammation. Ida does not start the fire. She reads the smoke. And the smoke in this case is the accumulating evidence of acetaldehyde's handiwork. Lisa was aware of all of this. She always is. The detoxification side of her operation, which handles a very large portion of the body's chemical processing, including most of what happens to drugs and foreign compounds, has a second enzyme standing by for acetaldehyde. It is called aldehyde dehydrogenase, and its job is to take that reactive protein-modifying molecule and convert it into something far less troublesome: acetate. Acetate is manageable. The body can use it, export it to other tissues, work with it in relatively ordinary ways. It is, in comparison to acetaldehyde, almost polite. But aldehyde dehydrogenase also uses NAD+ to do its job. Which means this second step, the step that should neutralize acetaldehyde, also contributes to the rising tide of NADH. The same NADH that Nancy had been watching accumulate since the first moment ethanol arrived. The same NADH that was now beginning to press on the reactions Lisa needed to run. Nancy, flat and elongated, cool blue-gray with that faint luminous sheen, her face composed and unreadable, did not editorialize. She simply noted that the ratio had shifted further. There was less NAD+, and in the chemistry of a cell, that ratio is not a passive accounting figure. It actively changes what reactions can proceed. NADH and NAD+ are two forms of the same molecule. NAD+ is the empty carrier, ready to accept electrons and do useful work. NADH is the loaded carrier, full and waiting to be emptied. When NADH accumulates faster than it can be cleared, it piles up like unreturned shopping carts in a parking lot. Reactions that depend on NAD+ find the shelves bare. Reactions that produce NADH find their product backing up. Gluconeogenesis, the process of building new glucose that Gerald had been counting on, is one of those reactions that needs NAD+ to run cleanly. And now, the supply was stretched thin. Gary had already noticed. The loading dock at his glucose warehouse had slowed. Outbound shipments were not where he wanted them to be. He was doing the math quietly, as he always did, keeping his accounting tight without complaint. But numbers, as he well knew, had a way of eventually demanding attention. And somewhere, further upstream, in the chemistry of the portal vein and the steady hum of Lisa's cell, the acetaldehyde was still reaching. Somewhere in the middle of all that chemistry, the acetaldehyde reaching, the NADH climbing, Gary quietly revising his dispatch schedule, Lisa kept one eye on a different department entirely. Because the work of the night does not pause for any one problem. The body does not grant extensions. She had bile to finish, not start, finish. The hepatocytes, the main working cells of the liver, packed dense and busy as any room in the building, had already done the early synthesis hours ago. They had taken cholesterol, the same molecule everyone worries about in a different context, and they had bent it, shortened it, attached molecules of glycine or taurine to the end, making it water-soluble enough to travel. That was the conjugation step, and it mattered more than it sounds, because bile salts need to work in a watery environment, the gut, while also reaching into fat. They are, in a sense, bilingual, comfortable in both worlds, but the hepatocytes hand the bile off before it is done. It moves into a branching network of tiny channels, and that is where the cholangiocytes take over. Cholangiocytes are the cells that line the bile ducts, the plumbing. They add water. They add bicarbonate. They adjust the chemistry of the fluid itself, making it more alkaline, tuning it for the acidic environment it is about to meet in the upper small intestine, where the stomach's acid output arrives first and everything downstream needs careful buffering. Lisa had always appreciated the cholangiocytes. They did finishing work, quiet, precise, unglamorous. Nobody writes songs about the cells that line the ducts. But without their contribution, the bile arriving at the gallbladder would be a rougher product. The gallbladder is a small pear-shaped pouch that sits just under the liver, and its job is patient and singular: concentrate and store. Bile arrives, water is pulled out, and the bile salts and phospholipids and cholesterol and conjugated bilirubin all grow more concentrated, up to 10 times more concentrated than when they left the liver. The gallbladder holds this concentrated reserve until a meal comes through and the signal arrives. That signal has a name: cholecystokinin, a hormone released by cells in the small intestine when fat and protein show up. Cholecystokinin reaches the gallbladder, and the gallbladder contracts. The bile is released into the duodenum, the first stretch of the small intestine, and it arrives just as the fats from that meal are also arriving, tumbling in from the stomach, globules of fat in a watery environment, which is a problem because fat and water do not naturally mix. And this is the moment, the one that unlocks everything else. Bile salts surround those fat globules. They are amphipathic, another word that means exactly what you need it to mean here. One end of the molecule loves water, one end loves fat. The bile salts arrange themselves around the fat-loving end facing in, water-loving end facing out. They break the large globules into smaller droplets. That is emulsification. And the smaller the droplet, the more surface area the digestive enzymes, lipase, arriving from the pancreas, have to work on. More surface area means faster digestion. Faster digestion means more products to absorb. Those products, fatty acids and monoglycerides, then get packaged into even smaller structures called micelles. Micelles are tiny, organized spheres, again with the water-loving surfaces facing out into the gut fluid, and the fat-soluble contents tucked safely inside. And the fat-soluble contents are not only the digested fats themselves. This is the part that catches people off guard. Vitamins A, D, E, and K are fat-soluble. They do not dissolve in water. They cannot travel through the watery environment of the gut on their own. They need to be carried, and the carrier is the micelle. Without bile salts forming micelles, those 4 vitamins, regardless of how much of them you consumed, cannot cross the intestinal wall in meaningful amounts. They are present but inaccessible. The door exists, but the key is bile. Vitamin A, which the body uses for vision and immune function and cell growth. Vitamin D, which the body uses to regulate calcium and support bone and immune signaling. Vitamin E, which functions as an antioxidant in cell membranes. Vitamin K, which is essential for blood clotting and for the activation of certain proteins involved in bone metabolism. 4 vitamins, whole categories of biological function. All of them dependent, in the end, on what Lisa does quietly in the background before any meal is even over. She had explained this once to Gerald during a slow hour, and he had given her the expression of a man absorbing information he did not need but could not dismiss. But he understood infrastructure. He understood what it meant when a system quietly held everything else up. Gary, for his part, had said nothing. Gary respected any operation that ran on schedule. The bile system ran on schedule. That counted for something. The micelles had formed. The vitamins were aboard. The small intestine would do its part, the enterocytes absorbing what arrived, the lymph carrying the fat-soluble cargo away in chylomicrons. But that was downstream work, and Lisa did not follow every shipment to its destination. She had other things arriving. The NADH ratio was still climbing. Ida had been quiet for a few minutes, but quiet was not the same as gone. And the night, such as it was in a body that never quite went dark, was moving steadily toward its middle hours. There is a particular kind of problem that does not announce itself with sirens. It arrives quietly, like a slow shift in the tide, and by the time you notice the waterline has moved, it has been moving for a while. That was exactly the kind of problem Liver Lisa was managing right now. The NADH was rising, not in one dramatic surge, but steadily, a tide coming in, one reaction at a time. Every molecule of ethanol that alcohol dehydrogenase converted to acetaldehyde consumed 1 molecule of NAD+, and left behind 1 molecule of NADH in its place. And then, just downstream, aldehyde dehydrogenase converted acetaldehyde to acetate, and did the same thing again. Consumed another NAD+, produced another NADH. NAD plus Nancy had been trying to keep up. That was, in a sense, her whole job, cycling between her oxidized form and her reduced form, carrying electrons from one reaction to the next, keeping the chemistry of the cell turning over like a well-maintained engine. But she could only do what the reactions allowed. And right now, the reactions were converting her in one direction, faster than she could be recycled back. She noted it without drama. The ratio, she would say, had shifted, and the ratio, it turned out, was everything. Here is the thing about NADH. It is not simply a byproduct. It is a signal. When NADH rises relative to NAD+, the cell reads that as a sign that plenty of fuel has arrived, and that certain kinds of energy-producing work can slow down. The problem was that alcohol was not exactly fuel in the usual sense. It was something the liver had to process regardless, first and before almost anything else. And the NADH it produced was a chemical side effect of that processing, not a genuine report of abundance. But chemistry does not read intentions, it reads concentrations. And so the cell responded to the rising NADH the way it always responded. It began to pull back from processes that require NAD+. Gluconeogenesis, the building of new glucose from scratch, requires NAD+. Gerald had already noticed that. His call after midnight had been about exactly this. The gluconeogenesis line was backed up. The outbound glucose queue was slowing, and no one downstream was particularly happy about it. Glycogen Gary had been running his own calculations at the loading dock, watching the numbers on his outbound shipments, and quietly revising his estimates downward. But gluconeogenesis was not the only process in trouble. Fatty acid oxidation, the burning of fat for energy, also requires NAD+. Normally, the liver is a quiet and efficient fat burner, breaking down fatty acids through a process called beta oxidation, a stepwise dismantling of fat molecules that feeds their carbon fragments into the energy-producing machinery. It is not glamorous work. It is the kind of work that happens all the time, steadily, without anyone particularly noticing. With NADH rising and NAD+ in shorter supply, beta oxidation began to stall. Fatty acids that would ordinarily have been dismantled and used were instead left waiting. And waiting in a liver cell does not mean they simply sit politely in a queue. It means they get redirected. The cell, reading high NADH as a signal of energy abundance, also began to shift gently towards synthesis rather than breakdown. Lipogenesis, the building of new fat, was nudged upward. Fatty acids that were not being oxidized began to be esterified, packaged into triglycerides, and deposited within the liver cells themselves. Lisa was, in the most chemical sense possible, beginning to accumulate fat she had not asked for and did not particularly want. Now, this is exactly the moment to be careful about what this means and what it does not mean. Fat accumulation in liver cells under these conditions is a real and documented effect of heavy alcohol use over time. It is the beginning of what is sometimes called alcoholic fatty liver. And here, the story requires a deliberate pause, because there is another condition, one that is increasingly called metabolic dysfunction-associated steatotic liver disease, that also involves fat accumulating in liver cells. And that condition is explicitly defined by not being caused by alcohol. The two can look similar under a microscope. They have different origins. In a story about alcohol, that distinction has to be named out loud, or the listener quietly merges what should be kept separate. What was happening in Lisa's cells right now was a consequence of the altered NAD plus NADH ratio, a direct downstream effect of ethanol metabolism. The chemistry had changed direction, and the fat was following. Lisa was not alarmed. She had seen this before. She understood the mechanism the way a veteran plumber understands a slow drain, not as a catastrophe, but as a system under a particular kind of stress, responding in entirely predictable ways. The predictability was almost reassuring. Almost. Ida was still there, quieter now, but monitoring. The protein adducts that acetaldehyde had left behind were not invisible to her. Modified proteins still looked wrong, and Ida's nature was to respond to things that looked wrong. She had not escalated, but she had not stood down either. Gary was recounting his inventory with the methodical patience of someone who has learned not to panic and not to pretend. The numbers were what they were. The shipments would go out or they would not, depending on what the chemistry allowed. And Nancy, NAD plus Nancy, kept cycling as fast as the cell permitted, which was not as fast as she would have preferred. The ratio had shifted. She had said so. The consequences were simply catching up, one department at a time. The consequences, as Lisa had noted, were catching up one department at a time, and Gary was feeling it first. Glycogen Gary, the liver's on-site warehouse manager, a squat honey-brown fellow who looked, if you used your imagination, like a compact bunch of grapes with arms and a resigned expression, had been running his loading dock since sundown. His job was simple in concept: store glucose when the body had more than it needed, then release it steadily through the night, parceling out small shipments to the brain and muscles, while the rest of the body slept and asked nothing of the kitchen. Simple in concept, less simple when the chemistry of the entire building was quietly rearranging itself around him. He could feel the slowdown. The orders were coming in from Gerald, Glucagon Gerald, that compact amber gold figure who served as the body's blood sugar ambulance, who only ever called at inconvenient hours and had long since stopped pretending to be surprised when something was backed up. Gerald's standing order was glucose, steady and reliable. Gary's standing answer was, the shipment goes out, one way or another. But one way or another was taking longer than usual, and Gary knew why. He had seen the NADH numbers. Nancy had flagged them herself, in her characteristically quiet way, and Gary had done the math. Here is what the math said. Releasing glucose from glycogen, that is, breaking apart the branched polymer chains Gary maintained so carefully, is one thing. But sending that glucose out as useful, regulated fuel requires the whole system to be running in something close to its normal chemical balance. And at the moment, the balance had shifted. The NADH surplus that had slowed gluconeogenesis, the process of building new glucose from scratch, which Gerald had been counting on since episode 3, was also making the broader metabolic environment less hospitable for smooth, efficient dispatch. Gary was still sending shipments. He was not stopping, but he was doing it the way a postal worker does when the sorting machine is down. Manually, carefully, slower than anyone would like. She always noticed. She had already done what she could about the fatty acid situation. She had watched beta oxidation stall, watched the triglycerides accumulate in the short term, and she had noted it the way she noted everything, precisely, without drama, with the full understanding that this was the chemistry doing what chemistry does when the ratio shifts. Nothing personal, entirely consequential. Now she turned to a different part of the operation. Bilirubin. This is one of the more remarkable pieces of work Lisa does, and it tends to go completely unnoticed until something goes wrong. Here is the plain version of it. Red blood cells do not last forever. They live for roughly 120 days, and then they are done. When they break down, the hemoglobin inside them, the protein that carries oxygen, is disassembled. The iron is saved and recycled because iron is precious, and the body knows it. But the heme ring, the non-iron portion of hemoglobin, cannot be recycled in the same way. It gets converted into something called biliverdin, and then almost immediately into bilirubin. Bilirubin, in its raw form, what the medical world calls unconjugated bilirubin, is not water-soluble. It travels through the bloodstream bound to albumin, hitching a ride until it reaches the liver. And the liver's job is to receive it, process it, and make it safe to excrete. Lisa does this through a process called conjugation. She attaches glucuronic acid molecules to bilirubin, 2 of them in most cases, converting it from a fat-soluble compound into a water-soluble one. That conjugated bilirubin can then be secreted into bile, travel down through the bile ducts, reach the intestine, and eventually leave the body in stool. It is, incidentally, the reason stool has the color it does. The chemistry of waste is also the chemistry of color. Now, here's where things get interesting. Alcohol puts pressure on this system. Not by breaking it outright. Lisa's conjugation machinery is not simply switched off by ethanol, but the liver is handling an unusual workload right now. The alcohol dehydrogenase pathway is running at full speed. Aldehyde dehydrogenase is cleaning up acetaldehyde. Inflammation Ida is pinging the cytokine signaling network because modified proteins look wrong to her, and she responds accordingly. NADH is high. Gary is slowing down. And in the middle of all of it, the bilirubin line still needs to move. What nobody tells you about the liver is that it does not get to pause one department while it focuses on another. There is no off switch for heme breakdown. Red blood cells do not stop dying because the ethanol processing queue is long. The bilirubin keeps arriving. And Lisa keeps conjugating it, fitting the work in around everything else, because that is what the night shift requires. NAD plus Nancy, for her part, was watching the conjugation process with the quiet professional attention she gave to every reaction that touched her. Conjugation itself does not directly consume NAD+, but the surrounding metabolic environment, the elevated NADH ratio, the altered redox state of the cell, can influence how efficiently the whole system runs. Nancy did not editorialize. She simply noted that the ratio had shifted and that the consequences of a shifted ratio tend to be wide. The ratio tells the story, she would say, if pressed. Lisa was not pressing anyone. She was working. The bilirubin line moved, slower than ideal. And in the loading dock, Gary kept sorting his shipments by hand, one parcel at a time, while somewhere upstream Gerald waited for glucose that was coming, one way or another, just not quite on schedule. So there was Gary, hand-sorting glucose shipments in a loading dock that had slowed to a fraction of its usual rhythm. And there was Gerald, somewhere upstream, waiting with professional patience for an order that was technically on its way, just delayed. Lisa knew both of those things at once, the way only someone who runs multiple departments simultaneously can hold two problems without letting either one steal her full attention. But here is the thing about a liver running through an ethanol event. It does not just slow down in one place and carry on normally everywhere else. The chemistry is shared. The same cellular environment that houses the alcohol dehydrogenase reaction also houses the rest of the work. And when the NADH ratio shifts, it does not shift selectively. It shifts for everyone. Lisa had another tool. She had been reaching for it quietly, the way a good department head keeps a secondary process running without calling a meeting about it. It is called ketogenesis. Here is what that means in plain language. When fatty acids cannot complete their normal journey through beta oxidation, when that pathway is stalled because it needs NAD+, and the NAD+ supply has been drawn down by alcohol metabolism, some of those fatty acids take a detour. They travel to the mitochondria of the liver cells and are converted there into molecules called ketone bodies, specifically two of them, acetoacetate and beta-hydroxybutyrate. Think of them as a kind of portable fuel packet. Not glucose, something else, something the brain and the heart and the muscles can actually use when glucose is short. Lisa had not advertised this. She rarely did. Ketogenesis is not dramatic. It does not announce itself. It simply opens a side door when the main corridor is backed up and starts sending a different kind of shipment toward the bloodstream. In ordinary life, say during a long overnight fast, or during the kind of sleep where dinner was modest and the last meal was hours ago, ketogenesis runs at a gentle background hum. The liver makes a modest quantity of ketone bodies to supplement whatever glucose the brain is drawing down. It is a normal part of the body's fuel management, a quiet backup system that most people will never think about, and the liver will never explain. But on a night when ethanol metabolism has elevated NADH, when beta oxidation is genuinely slow, and fatty acids are accumulating in ways Lisa would rather they did not, ketogenesis picks up. Not in a way that resolves everything, but meaningfully. The side door opens a little wider. And here is the quiet irony that Lisa had come to accept over many years of night shifts. The same metabolic situation that was slowing Gary's glucose dispatch, the high NADH, the stalled fat oxidation, was also nudging the conditions that favor ketone production. The problem and the partial workaround were arriving together. The liver, as usual, was working with what it had. She kept an eye on the acetyl-CoA level. That is the molecule at the junction, the one that fatty acid breakdown produces, and that can either enter the main energy cycle or be redirected toward ketone synthesis. When the energy cycle is slow, and elevated NADH slows it, because certain steps in that cycle also require NAD+, acetyl-CoA tends to accumulate. And when it accumulates, the liver has a decision to make: route it toward ketone bodies, or let it sit. Lisa routed it. Not all of it. The liver does not work in absolute decisions. It works in ratios and gradients, in enzymatic preferences that shift as the chemical environment shifts. But the direction was clear. Some of the acetyl-CoA that would have proceeded normally through the energy cycle was instead being assembled into acetoacetate, and some of that acetoacetate was being reduced, and here is where the elevated NADH actually became useful for once, reduced into beta-hydroxybutyrate. That reduction requires NADH. The same molecule causing the traffic jam was powering the side road. Biology occasionally has that quality. The thing that causes the problem is also the thing that partially addresses it. Lisa had stopped finding this surprising. It was simply the logic of a system that had been running for a very long time. NAD plus Nancy, observing this from her position somewhere in the enzymatic machinery, noted the pattern without commentary. She had been consumed and produced and consumed again in a dozen reactions by this point in the shift. The ratio had shifted. Some of the resulting NADH was now being used. That was, in the strict accounting sense, fine. She did not have preferences. She had states. The ratio tells the story, Nancy might have said, if she had been in the mood for summary. And the story it was telling right now was that the liver was mid-adaptation, not in trouble, not resolved, mid-process, the way most interesting biological events are. Out in the loading dock, Gary registered the arrival of a different kind of shipment in the bloodstream. Not glucose, ketones. He had seen this before. He filed it under the category of things that were not strictly his problem, but that he tracked anyway, because a good logistics manager knows what else is moving in the system. The glucose line was still slow. That had not changed. Gerald was still waiting, with his characteristic flat professionalism. But the body, in the meantime, was not simply idle. A different kind of fuel, traveling a different route, keeping things functional, while the main supply chain worked through its backlog. Lisa noted the ketone levels, adjusted nothing, and moved on to the next item on a list that had no end in sight. Lisa noted the ketone levels, adjusted nothing, and moved on to the next item on a list that had no end in sight. And the next item was this. Acetaldehyde was still in the building. Now, the ketone detour had been a reasonable workaround. Fuel was flowing. Gary's shipments were slowed, but not stopped. Inflammation, Ida, was doing what she always does, flagging the unusual, sending signals, keeping the record. All of that was, in the grand scheme of a difficult shift, manageable. But acetaldehyde has a particular quality that Lisa had not forgotten. It does not wait politely. It reaches out and touches things. Here is what that means in plain language. Most molecules inside a cell are minding their own business, doing their assigned job, moving along their assigned path, carrying no particular charge about the molecules next to them. Acetaldehyde is different. It is what chemists would call reactive. It forms bonds with proteins it was never supposed to meet. It attaches to the surface of enzymes, structural proteins, even DNA-binding proteins, forming what are called adducts, which is a technical word for an uninvited modification. The protein still exists. It just no longer does exactly what it was built to do. Lisa had already clocked this hours ago, when Ida first raised her spiky silhouette and said, in her matter-of-fact way, that certain proteins were looking wrong to her, and she was responding accordingly. That was the cytokine signal going out. That was the NFKB pathway opening up. That was acute, appropriate, necessary inflammation, the immune system reading a real problem and answering it. But Lisa's concern right now was not Ida. Ida was handling herself. Lisa's concern was glutathione. Glutathione is a small molecule, 3 amino acids linked together, and it is, without much exaggeration, the liver's primary antioxidant. Its job is to neutralize reactive molecules before they can do the kind of damage that accumulates into something serious. It donates electrons. It absorbs the chemical insult so that the cellular architecture does not have to. Hepatocytes keep a substantial reserve of it because the liver, by the nature of its position, filtering everything that comes in through the portal vein, encounters reactive molecules on a more or less permanent basis. Glutathione is ready for that. That is the whole point of keeping reserves. What glutathione is not built for is a sustained, high-volume demand. And acetaldehyde, arriving in quantity over an extended stretch of the night, creates exactly that. Each time glutathione neutralizes a reactive molecule, it is oxidized in the process. The used form is called GSSG, oxidized glutathione, and the cell does have a way to recycle it back to the active form. That recycling pathway uses NADPH, a cousin of NADH that runs its own set of reactions. The cell can regenerate glutathione given time and the right conditions. The problem is that regeneration takes time. And acetaldehyde does not wait. So as the metabolism of ethanol continued, alcohol dehydrogenase converting ethanol to acetaldehyde, aldehyde dehydrogenase pushing acetaldehyde onward to acetate, the glutathione reserves were being drawn down. Molecule by molecule, faster than they were being replenished. Lisa tracked this the way she tracked everything. Steadily, without alarm, with the quiet arithmetic of someone who has done this before. The reserves were not gone. The liver does not abandon its defenses in one shift. But the margin was narrowing, and a narrower margin means that other reactive molecules, ones that would normally be neutralized without incident, now had a slightly longer window to do their work. This is the part of the story that nobody usually tells. People understand in a general way that the liver processes alcohol. What they do not picture is the downstream competition for resources. Acetaldehyde does not just pass through and leave everything else untouched. It competes. It draws on the same reserves that the cell uses to handle everything else that arrived through the portal vein. The trace compounds, the metabolic byproducts, the ordinary cellular business of a body in the middle of a night. Nancy, the flat blue-gray molecule who had been running harder than she preferred for the last several hours, offered her usual observation without sentiment. The ratio, she noted, had shifted. It was still shifted. And now, glutathione was feeling the same pressure from a different direction. Not the same mechanism, same origin. Ethanol metabolized into acetaldehyde, which modified proteins and depleted glutathione. Ethanol metabolized with NAD plus consumed, which raised NADH, which slowed gluconeogenesis and backed up Gerald's call. Ethanol metabolized continuously, which redirected fatty acids towards storage rather than burning. One molecule, several simultaneous consequences, each one a separate thread pulling on a different department. Lisa did not editorialize about this. She simply kept the glutathione recycling pathway running as efficiently as conditions allowed, noted that the reactive load was elevated, and logged the state of the reserves. She was not worried, exactly. Worry is a luxury for short-term thinking, and Lisa's thinking is structural. She was noting a pattern, the way a skilled night shift manager notes the early signs of a supply chain strain, not because the shift is lost, but because information is more useful than surprise. Somewhere in the larger cellular quiet, Ida kept her slow rotation, her spikes catching the low light. She had not stood down. She was not standing down. Modified proteins were still arriving at her attention, and she was still logging them. She had no opinion about the glutathione situation. That was Lisa's department. Ida's department was simpler. Something had caused this, and she had not started it. The night moved on. The acetaldehyde continued its conversion toward acetate. The reserves continued their slow draw. And Lisa moved to the next item, which was already waiting. The reserves continued their slow draw, and Lisa moved to the next item, which was already waiting. Here is something worth understanding about how the liver handles alcohol. Alcohol dehydrogenase, the enzyme we have been watching all night, is not the only pathway Lisa uses. It is the primary one, the one that runs first, the one that handles most of the load under ordinary circumstances. But when the load is heavy, when the volume coming through the portal vein keeps arriving, a second system activates. And this second system has a name that sounds like a code, because it essentially is one. It is called the microsomal ethanol oxidizing system, and it lives in a family of enzymes you may have heard of in a different context, the cytochrome P450 enzymes. Now, cytochrome P450, that name, it sounds like something from a chemistry lecture, and the temptation is to let it blur past. So here is the plain version. Cytochrome P450 enzymes are a large family of proteins embedded in the membranes inside liver cells. They are some of the most important detoxification tools Lisa has. Most drugs you have ever taken, prescription or otherwise, pass through at least one member of this family before leaving your body. They are Lisa's chemical editing department. They take substances that the body cannot easily eliminate and transform them into forms it can. The specific member of this family that handles alcohol when the primary route is overwhelmed is called CYP2E1. And here is what makes it interesting. Under low alcohol conditions, CYP2E1 keeps a low profile. It is not the first responder. But when ethanol levels are high, when alcohol dehydrogenase is running as fast as it can and ethanol is still accumulating, CYP2E1 is induced. That word induced means the cell actually ramps up production of this enzyme in response to the demand. More ethanol arriving over time means more CYP2E1 available to handle it. The liver is, among its many qualities, adaptive. But adaptation has a cost. It almost always does in biology. CYP2E1, as it converts ethanol, produces something beyond acetaldehyde. It generates reactive oxygen species. These are molecules with unpaired electrons, chemically unstable, highly reactive, prone to grabbing electrons from nearby structures and damaging them in the process. Proteins, lipids, even strands of DNA can become targets.
The body has defenses against reactive oxygen species, glutathione being one of them, which is why we have been watching Lisa's glutathione reserves all night. But CYP2E1's activity adds directly to the oxidative load that glutathione is already working against. So here was the situation in Lisa's department at this hour. The primary alcohol dehydrogenase pathway was running, converting ethanol to acetaldehyde and producing NADH in the process. That elevated NADH was still pressing on gluconeogenesis and on Gary's dispatch schedule. Gerald's thread, still unresolved, still humming in the background. Aldehyde dehydrogenase was clearing acetaldehyde to acetate, also consuming NAD+. Inflammation. Ida was tracking acetaldehyde, modified proteins, and maintaining her quiet vigil. Glutathione was being drawn down faster than it was being replenished. Ketogenesis was running its alternate route. And now CYP2E1 was adding a parallel ethanol oxidizing lane. Useful, necessary even, but generating reactive oxygen species that arrived as yet another demand on an antioxidant defense already stretched thin. There is a word for this kind of situation: competition. Not competition between departments fighting for territory, but competition between legitimate needs for the same limited resources. The cell has only so much glutathione. It has only so much NAD+. It has only so many structural proteins that have not yet been modified by acetaldehyde. Every active pathway is drawing from the same finite pool. NAD plus Nancy, cool blue and steady as ever, was at the center of it. She had been at the center of it in episode 3, when Gerald first called about the gluconeogenesis slowdown. She was at the center of it now. The ratio had shifted. That was her observation, offered without drama, because drama was not her department. NAD+, being consumed faster than it could be regenerated, meant the cellular environment leaned NADH heavy. And an NADH heavy environment changes what reactions run, what runs slowly, and what effectively parks until conditions improve. The ratio tells the story, she might have said, had anyone thought to ask her. The ratio always tells the story. Lisa noted the CYP2E1 activity in her running inventory. Not as a problem exactly. A problem implies something unexpected. This was simply the predictable consequence of a heavy workload cascading through interconnected systems, each one doing exactly what it was designed to do, each one drawing from resources shared with the others. The liver is not a machine that processes inputs and outputs cleanly, one at a time. It is a living chemical ecosystem. Change the input, and the chemistry reorganizes, not just in one reaction, but in dozens simultaneously. Deep in the cells, the reactive oxygen species produced by CYP2E1 continued to appear. Glutathione continued to intercept what it could. The reserves continued their measured decline. And Gary, over at the loading dock, was watching his outbound queue with the particular expression of someone who has done this long enough to stop being surprised. The shipments were slower. The numbers were clear. He had already recalculated what the morning shift would need to compensate for. Somewhere upstream, Gerald was still waiting on his gluconeogenesis order, still patient in the way of someone who has learned that patience is simply what the job requires. Lisa moved through her list.
The night was not finished with her.
Lisa moved through her list. The night was not finished with her. Here is something most people never think about. When you take a medication, any medication, it does not simply dissolve into your bloodstream and do its job forever. At some point, it has to be dismantled, made water-soluble, prepared for the exit, and a very large share is here in the liver, along a particular chemical assembly line that Lisa runs with quiet, practiced efficiency.
The assembly line has a name: drug biotransformation.
The workers on that line belong mostly to a protein family called the cytochrome P450 enzymes.
They are a large family, dozens of individual enzymes, each with slightly different preferences, slightly different tools. Together, they handle the metabolism of an enormous range of compounds: prescription medications, over-the-counter drugs, plant compounds from food, environmental chemicals that drift in uninvited. If a molecule needs to be chemically modified before the body can remove it, there is a reasonable chance a cytochrome P450 enzyme is doing the modifying. Lisa oversees this department the same way she oversees everything else, steadily, without announcement, one molecule at a time. Now, here's where the story gets interesting. One member of that cytochrome P450 family, CYP2E1, the same enzyme Lisa activated earlier when the alcohol load grew heavy, is not exclusively an alcohol processing enzyme. It shares its workspace with the rest of the drug biotransformation line. Same cellular neighborhood, same pool of chemical resources. And when alcohol arrives in quantity, CYP2E1 gets busy. Lisa had already noted this a few hours ago when the ethanol load exceeded what alcohol dehydrogenase alone could handle. CYP2E1 stepped in as the secondary pathway, converting ethanol to acetaldehyde, and in the process, generating those reactive oxygen species that further strained the glutathione reserves. That part of the story has already been told. But there is a downstream consequence that belongs to a different department entirely. When CYP2E1 is running hard on ethanol, it is less available for everything else on the biotransformation list. The drug metabolism lane gets narrower. Compounds that would ordinarily move through the cytochrome P450 system at their expected pace now find the traffic slower, the processing backed up. Some medications that depend on this system for their breakdown may linger longer than they otherwise would. Others, in a different scenario, might be processed too quickly if the enzymes are in a different state of activity. The relationship between alcohol and the cytochrome P450 system is not a simple one-direction story. It depends on timing, on quantity, on which direction the enzyme activity is leaning. Lisa did not editorialize about any of this. She simply noted the congestion at the biotransformation desk and kept working. NAD plus Nancy, meanwhile, was tracking the ratio with her usual unspoken precision. The conversion reactions had been running for hours now. NAD plus had been consumed steadily, first by alcohol dehydrogenase, then by aldehyde dehydrogenase, the enzyme that converted acetaldehyde to the less reactive acetate. Both reactions drew from the same Nancy pool. Both left NADH behind. The ratio had shifted significantly from where it had been
at the start of the shift. And Nancy's quiet accounting made clear that this was not a brief fluctuation. This was a sustained reorganization of the cellular chemistry. She did not editorialize either. The ratio tells the story. She had said so before. She would let the numbers speak. Glycogen Gary, out at the glucose dispatch dock, had been watching the NADH numbers with the patience of someone who has been watching numbers for a very long time. The gluconeogenesis line, the one that builds new glucose from non-sugar precursors, was still running below its usual throughput. Gary had made peace with this hours ago, in the way that overnight logistics managers make peace with things that are temporarily outside their control. He had adjusted his projections. He had redistributed what inventory remained in the glycogen reserves. He was doing the math quietly, continuously, on what was going out and what was still available. Glucagon Gerald had called earlier. Gary had not needed to explain much. Gerald understood the NADH situation. He had lived through it once already, in the episode before this one, when rising NADH was the precise mechanism that slowed Lisa's gluconeogenesis and sent Gerald into his familiar state of professional exasperation. Same molecule, same consequence, different shift. Gerald had simply said that someone had to answer the call, and Gary had said yes, and the shipment had gone out, reduced but out, and the brain had received what it needed. That thread was not fully resolved. It was simply being managed the way most things in a working organ are managed, not with drama, but with careful adjustment. Inflammation, Ida had settled into her monitoring posture. She was not escalating. The acetaldehyde load had not climbed further in the last hour, and while the protein adducts from earlier in the shift were still present, modified proteins do not unmodify themselves on their own. The immediate signal had not intensified. Ida noted this without relaxing entirely. She had been in this job long enough to know that a stable reading and a resolved situation are not the same thing. Lisa filed all of this in the way she filed everything, calmly, in order, without complaint. The drug biotransformation line was moving more slowly. The NAD+ ratio remained shifted. Ida was watching. The work continued. That was the thing about the liver's night shift. It continued regardless. The list did not shorten simply because the conditions had grown more complicated. Lisa picked up the next item and moved forward. Deep in the hepatocytes, in the small organized spaces where chemistry happens without announcement, the next phase was already beginning. And so the night deepened. Not with any sudden change, not with an announcement, just the way a river deepens as it moves further from the mountains, quietly, without ceremony, becoming something calmer and more sure of itself. Liver Lisa kept working. She always kept working. That was the thing about Lisa. The hours didn't matter to her. The deep hours and the early hours all looked the same from where she stood. One long, unbroken shift that happened to contain a sunrise somewhere near the end. Around her, the departments had found their rhythm. Gary was still at the loading dock, that squat, honey-brown cluster of a warehouse manager, shaped like a compact bunch of grapes, watching his numbers with quiet patience. The glucose shipments were moving slower than he preferred. They had been moving slower for a while now. Gary knew the reason. He had known the reason since the NADH ratio shifted hours ago. He wasn't angry about it. He had long since moved past angry. He was simply doing the math, adjusting the schedule, making sure the brain got what the brain needed. One parcel at a time. One quiet dispatch at a time. Gerald had called. Of course, Gerald had called. He always called. That compact amber gold peptide, smooth and professional, with the straight-line mouth of a man who has been interrupted at inconvenient hours one too many times and has made his peace with it. He had his information. Lisa had given him the honest answer. The gluconeogenesis line was backed up. The NADH was the reason, same as last time, same as it would probably be some other time down the road. Gerald had said nothing for a moment. Then he had said, simply, that he would manage. Because someone has to answer the call. And then he was gone, back to his work, never quite off duty. Ida was holding. Her warm red-orange spikes caught the dim light of the cellular environment, steady and watchful. She had responded to the acetaldehyde. She had done exactly what she was built to do, noted the modified proteins, flagged them, sent her signals. The cytokines had moved. The NF-κB pathway had opened. She had not been dramatic about any of it. She was never dramatic. She simply noted that something looked wrong and responded accordingly. That was always how she said it. She didn't start anything. Something else did. And Nancy, quiet, efficient Nancy, that cool blue-gray molecule with the faint luminous sheen, her two lobes representing two ends of a very important story. She had been consumed faster than she preferred. The ratio had shifted. NAD plus going down, NADH coming up, and every department in the building feeling the change downstream. Nancy never complained about it. She simply let the ratio speak for itself. The ratio always told the story. And the story, as the deep hours settled in, was one of a system that had absorbed the disruption and was now, slowly, quietly, working its way back toward balance. The bile ducts were still moving. That gentle, steady plumbing that ran from the hepatocytes through the cholangiocytes, gathering water and bicarbonate along the way, carrying the bile salts and the phospholipids and the conjugated bilirubin toward the gallbladder. The micelles had done their work earlier in the evening. They had gathered the fat-soluble vitamins A, D, E, K, and carried them across the intestinal wall. The fat had been emulsified. The digestion had happened, and somewhere in the body, vitamins that could not have crossed without Lisa's plumbing had crossed. That was always the part that deserved a moment of quiet appreciation. The work that nobody saw, doing the thing that everything else depended on.
That bilirubin line was running. That steady, patient process of taking the fat-soluble, unconjugated bilirubin, the waste product of old heme, old red blood cells given a dignified exit, and adding the water-soluble tag that would allow it to be carried out in the bile. Conjugation, a small word for a very important step. Lisa's hepatocytes had not paused that line. They never paused that line. Even when every other department was stretched, the bilirubin moved. And the ketone bodies drifted out into circulation. Acetoacetate and beta-hydroxybutyrate, the fuel that Lisa had been making in the deepest hours of the metabolic reroute. The brain had been grateful, even if the brain didn't say so. The brain rarely said so. Lisa set down the last report she had been reviewing, not because the work was finished. The work was never finished. She set it down the way a craftsman sets down a tool at the end of a long bench, not abandoning it, just acknowledging that the hardest part of the night had passed. The deep hours settled around her like a familiar blanket. The chemistry moved softly. The pathways hummed at a quieter register. And somewhere in the vast warm dark of a body that was finally drifting towards sleep, Liver Lisa simply continued. The liver hums, not loudly, not urgently, just that steady, low, patient hum of a building where the lights are always on and the work never fully stops. Liver Lisa moved through her departments the way she always did, on a deep night, not rushing, not pausing, just keeping the whole operation in motion, one step at a time, one reaction at a time. Somewhere along the bile duct, the morning's first quiet trickle of bile was already being shaped. The hepatocytes had done their part, building bile salts from cholesterol, wrapping bilirubin in its water-soluble coat, assembling the whole careful mixture. The cholangiocytes had added their water and bicarbonate. And now the gallbladder held it all, patient and still, waiting for a meal that would not come for hours yet. Bile, ready. Micelles, ready. Fat-soluble vitamins A, D, E, and K, waiting for their escort across the intestinal wall whenever morning brought them something to work with. Gary was still at the loading dock. He was always at the loading dock. His branched clusters of glycogen sat in the cool dark of the liver, like a warehouse that had seen a long night and was nearly through it. He had shipped what he could. The NADH ratio had made things slower than he would have liked, but the shipments had gone out. One way or another, they always did. He leaned against the wall and looked at his tallies. The brain had received its quiet, steady parcels of glucose through the night. The numbers were not perfect. They rarely were. Gerald had checked in an hour ago, or maybe 2. Time moved differently in the deep hours. He had noted in that dry, unhurried way of his that glucose levels had held, not thriving, holding.
Gerald was a man who appreciated holding.
It was, in his estimation, the professional outcome.
He would call again before morning if anything shifted. He always did. Someone had to answer the call, and Gerald had made peace with the fact that the someone was him.
Ida was quieter now. The acetaldehyde load had been heavier earlier in the night, and she had responded accordingly. Cytokines moving, NF-κB signaling doing its careful, measured work.
The modified proteins had looked wrong to her, and she had said so, the way she always did. Not dramatically. Now, the signal was softer. The reactive burden was easing. She did not declare victory. She simply noted that the current state of affairs was less alarming than it had been, and she kept watch.
Nancy was quieter too. The alcohol dehydrogenase reaction had been running hard earlier, consuming NAD+ and producing NADH faster than anyone would have chosen. The ratio had shifted. The ratio always told the story, and for a while, the story had been a complicated one. But the ethanol was processed now. The acetaldehyde had moved through aldehyde dehydrogenase and become acetate. The ratio was slowly, gradually finding its way back. Not all the way. Not yet. But the direction was right. The ketone bodies were still moving through the bloodstream. Acetoacetate and beta-hydroxybutyrate, those quiet detour fuels that Lisa had routed through acetyl-CoA when the usual roads were backed up. They would keep circulating for a while yet. The brain was not unhappy about them. The CYP2E1 pathway had settled back to a lower idle. The cytochrome P450 enzymes were clearing their queue, slowly, in the methodical way of any system working through a backlog after the rush has passed. Glutathione reserves were still thin. The recycling pathway was still working to rebuild them, one quiet reaction at a time. That work would continue for hours. It did not need to be watched. It just needed to be allowed to run. And the bilirubin line was moving steadily. Unconjugated bilirubin, fat-soluble and stubborn, arriving from heme breakdown, being taken in by the hepatocytes, wrapped in glucuronic acid, made water-soluble, sent on its way into the bile. The plumbing that colored the world in quiet shades of amber and gold. All of it running, all of it continuing. Lisa walked the floor the way she had walked it 10,000 times before. Not inspecting, not supervising, just present, just aware. The body around her was deepening into sleep. The signals were slower. The demands were softer. The portal vein was quiet. The bile duct was patient. The glycogen sat waiting. The enzymes turned at their long, unhurried pace. This was the liver at rest, which is to say, the liver still working. Always working, just more softly now. And so the long shift settles.
The portal vein has gone quiet. No new arrivals, no fresh chemistry to reroute. The ethanol that came in hours ago has been walked down its long conversion path, from ethanol to acetaldehyde, from acetaldehyde to acetate, and the products have dispersed. The NADH that rose so sharply and caused so much downstream rearranging has begun slowly to come back down. Nancy notes this without ceremony. The ratio is shifting. The story it has been telling is changing tone. Gary is still at the loading dock. His ledger is quieter than he would like, but the shipments have not stopped. Small, steady parcels of glucose move out through the night, enough to keep the brain supplied, enough to keep Gerald from having to call again before morning. He does not say it is a good night, but he does not say it is a bad one either. The shipment goes out. That is enough. Gerald, somewhere upstream, has eased his signaling. The emergency tone is gone. When Lisa's gluconeogenesis line was backed up and Gary's dispatch was slow, Gerald held the line the way he always holds the line, professionally, without fuss, with the quiet exasperation of someone who has done this before and will do it again. For now, the call is closed. The glucose levels are stable. Ida has dimmed. The acetaldehyde adducts that caught her attention earlier are being processed, cleared, metabolized. Modified proteins have been flagged and handled. The cytokine signals she sent out have done their work. She is not gone. Ida is never entirely gone. But she is no longer ringing. She is watching. That is her nature. The CYP2E1 enzymes have stepped back to their resting rhythm. The cytochrome P450 family, which spent part of the shift running parallel ethanol oxidation, has room again to tend to other molecules in the queue. The glutathione reserves, drawn down hard during the oxidative peak, are being quietly restocked. Slowly, molecule by molecule, the recycling pathway is patient. Bilirubin moves through the conjugation line without interruption, fat-soluble to water-soluble. Packaged for bile, heading where it needs to go. It has been doing this all shift, and it will keep doing it. Bile itself flows steadily in its duct, calm and purposeful, carrying its cargo of salts and phospholipids and everything else the small intestine will need when morning asks for it. Liver Lisa sets down her pen, not because the work is finished. The work is never finished. But because the urgent part is through, and what remains is the steady, unhurried rhythm she knows better than anything. Metabolism, detoxification, storage, synthesis, the long, quiet list, working in parallel as it always has. She does not need to announce this. The body already knows. While you sleep, Liver Lisa is already at work. She is conjugating bilirubin and packaging it into bile. She is releasing bile salts that will be waiting in the gallbladder when morning and breakfast arrive, ready to emulsify fat and unlock the vitamins your cells are counting on. She is restoring glutathione, tending the glycogen stores, and keeping the chemistry in order. All of it, all at once, without a single request from you. Your body knows exactly what to do. It's been doing this work for your entire life. every single night. So let it, trust it, and as you drift deeper now,
Liver Lisa will be here when you wake up. Quieter, calmer, better. Sleep well.